All right. Hello, everyone. I've been asked to do a presentation for our student outreach. And my name is David Schwab. I am a lecturer at UTC, University of Tennessee at Chattanooga. And I've been a lecturer for, I think, it's either my sixth or seventh year. I've lost count at this point. And before that, I was an adjunct for a year. I'm also a PhD student at UTC, working on my doctorate in computational science with a concentration in computer science. And my area of research is cybersecurity. So today I'm going to give a brief overview of one of the courses that I love to teach. It's Computer Engineering 3700. And the title of the course is Digital Logic and Introduction to Computer Hardware. And the way that I describe this class to people is, maybe you've heard computers are built on ones and zeros. It's all ones and zeros. Well, that's really true. Binary is all ones and zeros. And so this course starts at the ones and zeros and builds up from there. So it's a very low level course. If you think about, you've got your ones and zeros here, and then you've got all the pieces of the computer, the CPU, uh, the memory, the RAM. That's the next level. Then the next level up would be your operating system, Windows, for example, or Mac OS, or on a phone, iOS or Android. And then on from there, you've got programs that run on the operating system. And so that's kind of a very basic view. So we're starting at the bottom level with this course with the ones and zeros. Of course, a computer also runs on electricity, and that gets into the electrical engineering aspect of things. And we don't talk about that so much in this course. We start at the ones and zeros and build up from there. So what I'm going to do is share my screen, talk about just some basic things, kind of give an overview of what I'm going to talk about, and end up with a demonstration at the end of this for one of the lab projects that the students will be working on. So the goal today is going to be to do a basic overview of binary, that is 0 and 1, very quickly cover some arithmetic with binary. There's only two values, 0 or 1, so how hard can it be? Uh, and then we'll talk about something again. These are all just, very quick overview, and I'm going to tie it into some computer simulations as well. And you can see this circuit over here, and I'll get to where I'm describing some of what's going on over here. Obviously, we're not going to get into a whole lot of detail about that. This is the culmination of about 8 to 10 weeks worth of learning before the students build something like this. This is lab 3 out of 4 labs that they'll be doing this semester. And we'll also talk about truth tables. But remember, everything is built up on ones and zeros. So what do I mean by that, by binary? We can have a switch or a light, and we'd say 0 means that it's off, and 1 means that it's on. And so in a very basic sense here, I've hooked this up for demonstration. So forget about all this stuff over here right now. Just look at this little board. I've got some switches here, and I've got some lights. So we're going to take this switch 1, and down is off and up is on. I've connected this switch to the light to show. Can even zoom in a little bit here, might help. So I'm off and the light is off, and I switch it up and the light goes on. And everything we do is built on that basic principle in this course. I tell students, this is a deceptively simple course. It is all built on ones and zeros, but uh, you really got to study because we build up from there very quickly. So I said I'd very briefly go over some arithmetic, but that's the basics of binary. We can also treat the binary as actual just numbers, and so 0 plus 0 equals 0. That's pretty obvious. 0 plus 1 equals 1. 1 plus 0 equals 1. Here's the one that may not be as intuitive. This equals 2. But when you have a 1 plus a 1, you get a 0 plus a 1 carry. And so this is binary for 2. Like I said, this is just a basic overview, but it's something that we cover in the course in the first week of class. We go over arithmetic, and these are all 1-bit numbers, 1 bit and 1 bit, because they're all 1 digit long. Just also, bit stands for binary digit. So they cut out everything in the middle here and took BIT to make bit. You may have heard of a byte. 1 byte equals 8 bits. And we won't go on to megabytes or gigabytes or kilobytes or any of that in this brief demonstration. But, so there you go. There's the basics of binary. That's the first thing I wanted to cover. And also the basics of binary arithmetic. Now, another thing that we do in this course is called switching algebra. And why do we look at algebra? Some of you may be breaking out in a cold sweat thinking about algebra at this point. But again, how bad could it be? It's only zeros and ones. We do this because it allows us to build and manipulate the circuits we build. So this all over here, and like I said, we're not really going to get into how it works, but it's all based on switching algebra. You can come up with a mathematical formulation for how all of this works. And we're obviously not going to get there today. Like I said, this is a couple months worth of learning that led to this particular project. Speaking of projects, I also wanted to point out this little board. It's called the BBC3. And the very first week, actually 2 weeks of class, the students use a soldering iron and build this. This is a very hands-on class. I mean, there's a lecture component that's very much book learning, but we also do a lot of hands-on. We learn the book part of it, and then we also build the circuits. And like I said, for this, they learn how to solder and put this together. Another side note about this little board, and when I say put this together, I mean it's a flat board with nothing on it. They take every single piece and solder every little pin on it. All of these little connections here. So quite a project to start off on. And let me retrieve my power source here. This flashing light is also a clock signal. And remember, I said binary is on or off. That's all this is. It's just a signal that is switching between on and off. And you can control the rate of blinking with this little device here, which is called a potentiometer or a variable resistor. And getting into how that works is more electrical engineering again, so we don't really talk about that a whole lot, but that's what it's called. All right, switching algebra. Kind of took a little detour there. That happens. Like I said, it's going to be a quick overview. The three first functions we look at are the inverter, and here's a truth table for it. So if I have a switch and I want to look at how the inverter works, if the switch is off, the output from the inverter is on, and vice versa. 1 goes to 0. And I happen to have an inverter right here that I've plugged up, and I actually use switch 2 for it and light 2. So switch 2 is my input, light 2 is my output. So let's zoom in again here. And you see switch 2 is down, so it's off, but the light is on, so it's the opposite. Now if I turn the switch on, the light goes off. So that's one basic function. Another basic function is OR. And you want to think this is either or both. And so this one has two inputs, so we'll call it switch 2 and switch 1. What we want to do is look at every combination of inputs. There they are. Here's the output for OR. If both inputs are off, then the output is 0. But the output will be on in all three of these cases. And again, you're thinking either or both. If either one of them is on, so here switch 1 is on, here switch 2 is on, here they're both on. And in all three of those cases, the output is on. And then finally, we have AND. I have just enough room to do this. And for this one, you think only both. And I'll do a computer simulation of these two. So again, we put every combination of inputs here. So if they're both off, the output is off. If either one of them is off, the output is off. It's only on when they're both the switches are on. And so this is the way that I teach this class as well. You know, we're doing the lectures virtually right now, and so I've got this same setup. There we go. Got everything on here now. Got to move this over. So here's our inverter. This is a switch. It's at 0, which means it's off, and the output is on. And I switch it, and it changes. And that matches up what we have with the truth table here. With the OR, if either one of them is on, that one, or both of them together. And then finally the AND, they both have to be on. Excuse me. And these shapes here define these particular switching algebra functions that we just talked about. So those were the learning outcomes that I kind of wanted to get to for this course. We have different chips that implement these functions and more. Um, so now let's kind of get to the grand finale, and I wanted to show off this lab. And we talk about how to design a circuit like this. The students are presented with a problem, and the problem with this lab that they were asked to solve was in summary, you have 3 binary inputs, and you display the following on a 7-segment display. What is a 7-segment display? What's this right here? And the light's kind of washing out, so it's hard to tell, but I always tell students when we're in the classroom, I say, turn around and look at the clock. That's a 7-segment display. And the reason there are 7 segments, 1, 2, 3, 4, 5, 6, 7. So we're going to write every combination of 3 binary inputs. And we haven't really covered this, and I'm not going to cover this today, but just so you know, this is the numbers 0 through 7 in binary. Something we spend a great deal of time learning and talking about at the beginning of the semester in this course. When it's 0, we want to display a C. When it's 1, we display an E. We display a C again here for 2, and then S, and then 20, 20. So as you go through from 0 to 7, you should get CECS 2020. So that's the problem that the students are presented with. You know, again, in summary, there's a lab document that they look at. I can go ahead and pull up the lab document here. And so there it is. They have post-lab questions that they have to answer. And then here's where they do their design. This is a truth table. Remember I mentioned the 7-segment display? Well, the 7 segments are labeled A through G. So this is where their design starts. They fill this out and they decide how each part of the segment should be lit up. So let me do a bigger drawing here of the 7-segment display. This is A, B, C, D, E, F, and G. So if I was going to, and we're not going to do the whole thing, but I just want to show you the idea. To display a C, we need A, F, E, and D to be on. Because that's these 4 segments right here. 1 is on and 0 is off. And so we can go through then and fill out the rest of that table here. And that's where pretty much every design starts in this course, is it starts with the truth table. And then we learn techniques to distill the truth table down into some algebraic equations. The algebra maps to the circuit directly. Like I said, there's a mathematical equation that describes this circuit. And then they have to simulate the circuit on the computer. So that's what I want to jump to next. So here is that circuit built on a simulation. And you see here are the gates that I discussed. This one is different. We didn't talk about that one. We see here's our inputs, 0, 0, 0, and we have a C. 0, 0, 1 goes to E. 0, 1, 0, C again, S, CECS, Computer Engineering, College of Engineering and Computer Science. And then with a 2, 0, 2, 0. And that's it. So once they have that, they can figure out from this, and they map this to where to put the wires, and they physically build the circuit. And that's what I have here. And so I had to reuse some of my switches, so ignore these lights up here. We're just watching the little 7-segment display down here. And it's starting at a C because all the switches are off. And then I'll turn this first switch on, and I have an E. There's another C with the second switch on, CECS. And then there's my 2, 0, 2, 0. And so that is, like I said, the third lab that they do in this course. We had to redesign all the labs this semester just a bit because we had to do a lowered lab capacity, and all the students are working alone on each lab instead of in partners. And so it's been good to have some kind of fresh ideas. So at this point, I would answer questions, except this is pre-recorded. So hopefully you found this demonstration interesting. And like I said at the beginning of this video, this is one of the courses that I really do enjoy teaching. It's a foundational course. It's something that sets the students up to really start understanding how the computer works, because like I said, it's that very bottom level, and we have a course for each of those levels I talked about. Like I said, this course at the bottom, ones and zeros. Then we have another course called Computer Architecture, which builds on this course. And so one way to kind of look at that is you've got all these chips and ways of connecting chips to do interesting things. Now, how can we make a computer out of all that? And then on top of that, we have another course called Introduction to Operating Systems. So how do you start having computer software that actually interacts with the computer hardware? And then beyond that, we have programming, a lot of courses that deal with programming and all the levels up above that in the computer system. So thank you very much. I will say, if you have any questions, that you can go ahead and email me. So my email address is david-schwab at utc.edu. So feel free to email me any questions that you have, and I'll be happy to answer. Thank you so much.